Well, this meeting is being recorded, and again, kindly be sure to mute yourselves until the Q&A section. So I'd like to have a warm hello and welcome to Navitas Presents Data Sharing Using Modern Data Platforms. What is a cloud-native modern data platform, and why do you need one? What will the IT industry look like in 4 to 5 years, and what can you do today to prepare for it? Is it possible to break through the stigma of managing data infrastructure on the cloud? We're going to discuss all of this and more, so let's get started with a warm welcome to our featured speakers from Navitas Business Consulting, Siva Thoda, Vice President of Cloud Practice, and Sinu Talasia, Vice President of Strategy.
Thank you, Sabrina. Thanks for the warm introduction. So we're going to go through a few things about data sharing using modern data platforms. So Sinu will kick it off with our business profile and some other things that we have been doing here in the space. Sorry about the background noise. Sinu, go ahead and kick start. Yeah.
Good morning, everyone. Before we dive into the presentation, I would like to take a moment to thank everyone for the time to attend this meetup. Can you move on to the next slide, Sabrina? Next one. Yeah, at a high level, I want to talk about our core capabilities, then talk about data sharing trends, a quick overview, not dwelling deep into the trends. Then Shiva will kick it off with data sharing patterns and how Snowflake can help solve these data sharing challenges that we have today. Can you move on to the next slide? Thank you. We are a small women and minority-owned native firm. We started our journey 12 years back as a small IT service provider in the financial and healthcare space, and eventually matured into a strong IT solution provider with the focus on data and cloud. Our core capabilities are cloud enablement, digital transformation, data and intelligence. I'm proud to say that we have been witnessing rapid growth in recent years, including several mission-critical projects that we are executing at DHS, USES, CBP, and a lot of modernization efforts in the commercial and state governments, commercial clients like Freddie Mac, Fannie Mae, PPOC. I personally attribute all this success on three of our core guiding pillars: our people, partnership, and culture. We are also have a partner relationships with AWS, Azure, GCP, and a strong relationship with the Snowflake data platform. Can you move on to the next slide? Shiva, we see your. Yeah. All right. So I've been fortunate enough to work on multiple data programs at various Fortune 500 companies over the last two decades. Almost every client I work with either is planning or building their third generation data analytics platform, while admitting the failures of the past generations. So the data 1.0, I would call it, this came like 2 decades before, where we had data warehouses and data marts built in using legacy tech tools like Oracle, and there was like extensive ETL transformation. All the data was done using batch processing, and there were some reports, and the file vending was done using like a flat files, and there were some batch jobs kicking up in, and data exchange was done internally and externally using this. I've also seen big systems like payroll processing, PeopleSoft, and these kind of systems also do a heavy data exchange in terms of flat files. Everything was batch, and there was fixed length and fixed formats that the teams were dependent on. Then later in 2020s, companies started using data lake. So the concept is centralized storage and federated compute. And we have seen big data systems like Hadoop, and people started making the journeys to the cloud and using things like S3-based data lakes or blob storage-based data lakes. Then the data was again done. There were a lot of ETL pipelines that were created to transform and parse this data from the source systems into this data lake, and from there to different data marts. So the concept was ingest, write once and read many times. So there's a new concept that came up. It's called ELT, which is different from the ETL. Then companies started plugging in the machine learning, and data portals were created. Some of them are open source, and companies started creating this API-based data exchange. So the first generation is all led into like technical depths in terms of unmaintainable ETL jobs and tables, and there are only small group of specialist people understanding and resulting in an underrealized positive impact on the business. Whereas this data lakes, the companies thought that's the silver bullet, but it became a complex data ecosystem with long-running bad jobs operated by central team. I would call them as like a hyper specialized data engineers, and companies have created data like monsters. And there was some kind of pockets of research and development activities using machine learning. And also the latest trend in this data lakes is creating like a real-time streaming or using like a Hitstep or Kappa architecture where they combine analytic workloads with transactional workloads. We have seen new open source concepts like Apache Beam doing like a combination of a batch and stream. We have seen Databricks, Spark, and all these things getting into the space. And the data pipeline execution and machine learning platforms are also built on top of this using the cloud-based managed services like in AWS SageMaker or the Azure-based services. Um, while these concepts are evolved, there was no domain-driven design and bounded context applied to data. It was only applied to the operational systems. We have seen emergence of cloud-native microservices. Everybody is talking about domain-driven, but when it comes to data, there was no domain-oriented concept. Everything was put together at one central base, and we created this big monster. So the latest trend right now that is happening is, we hear the concepts like lakehouse, data mesh, and data as a service is a new concept. Snowflake calls it data cloud. And we are also looking at new compliance-based data sharing and policies that are being put together, things like CCPA, GDPR, all this coming into play. People started looking at differently in terms of data sharing and how do I look at things like domain oriented. Having said that, I would like to move on to the next slide and talk about what is this a data mesh, right? Um, Data mesh is fundamentally built on four operating principles. The first one is domain-oriented decentralized data set. So before data lakes, where what we are doing is we are centralizing everything and we are using federated compute, but there is no domain-specific ways to create data marts. Here, the idea is every data has its own domain. So for example, if you are in an organization, you have multiple LOBs. Each LOB can be a specific data, or if you apply this microservice architecture concept, you can apply the same DDD techniques and create these data domains. And the second one is having a product mindset, which is not applied on the data. When we are talking about building these cloud native applications, we are looking at customer-centric design, product mindset. The same concept we want to apply in data and treat data as a product. So each domain, they have their data as a product, which will do the operational support as well as analytical support, and they'll have their own pipelines built for transforming the data. So the data domain owner is responsible for vending the data as well as consuming and providing the data as an API or secure data shifts or creating some microservices. And so in this scenario, when companies are looking at creating their own domains and treating data as a product, there will be a fundamental problem. Every LOB will create their own suite of technologies, and it's going to get a nightmare again. So the idea here is we need to have a centralized data infrastructure as a platform that has reusable infrastructure pipelines that can be made available to all these domains. So just like the concept of DevSecOps and CI/CD, there will be a central data engineering team providing this underlying data infrastructure, whether it's a Snowflake or any other tools that we are using. Everything is codified and available as an infrastructure, as a code or an API. So these platforms are the domain of the product owners. They get and consume and they write the programs for the transformation, but leverage the infrastructure that is already made available in terms of storage of the data, the security, applying the policies, and also creating these pipelines and setting up, creating APIs and real-time continuous deployment. When the data and infrastructure is shared and everybody is having their own domain, in terms of a mesh architecture, when a particular domain wants to consume the data of the other domain, if it don't have a governance, that's going to lead to a lot of problems in terms of DQ and also the interoperability. So the idea here is we wanted to have a global governance and create, and the council will be made of the people from each one of these domains. They go in and look at things like tagging, what is the metadata, what is the business glossary, so that the interoperability will become easier. And also, there are only the high-level policies that are governed by this centralized data governance team, which would be comprised of the individual partners from different domains. What are the attributes of the future data architecture? We are looking at distributed way of doing this and data owned by domain experts, and data pipeline serves the domain customer. And the biggest benefit that we get is cross-functional teams that can live in the data domain. And we are talking about this data being served as a service. Having said that, I would like to ask you, with this new architecture, talk about how Snowflake helps us in achieve the realize this data mesh concept with specific focus on data sharing. Thank you so much.
Thank you, Sino. Thanks for that wonderful tee up to this whole presentation. So I would like to spend a few more minutes about the data evolution part of it. If you look at the transition that is happening prior to 2000 and 2010s, and now we are in the 2020s, it's not like a regular cutoff that you basically go and actually do in the data 2.0 in 2010. That's not how industry works, right? So the fact that we have to be cognizant of when we actually talk about data cloud is the 3.0 and the later part of 2.0 coincide with the proliferation of cloud services. So that's probably the biggest shift that happened in 2010 and 2020, where the data architectures have been evolving the way they are evolving, trying to solve the data problems for the customers. So that's why it's such a critical when we say data cloud. The heart of the data would be served irrespective of the cloud CSPs right now in the industry, either it could be AWS, GCP, or Azure. So data cloud basically abstracts the CSP of choice and gives that seamless experience across the clouds and across the regions, even within the cloud. So having said that, there are like multiple ways, the way Snowflake operates in order to share the data. So first of all, why there is a constant need of data sharing, not just within the company, agency, or an agent or an enterprise, but enterprises don't work in silos. As you all know, there is a lot of need to kind of share the data sets between the enterprises or between the federal agencies or local businesses, how they wanted to serve their customers. So data asset and data democratization that they wanted to basically even commoditize or even commercialize some of the data sets that they have been trying to share with the marketplace. So there is a need that the continuous need to share the data across a partner ecosystem. So the way, the interesting way, at least Snowflake solves this problem is abstracting everything from you can see from 2010 and the pre-2000s, in order to evolve the way the data has been evolving, in order to support the use cases. So you would end up paying a lot of operational expense and the capital expenditure in order to stand up that infrastructure and keep on updating it and trying to do your traditional ETLs the way you wanted to prepare the data, cumbersome way, and you have a lot of data duplication. Needless to say, that was happening. So the data cloud construct that the industry is trying to move towards, the way Snowflake solves is, so you have a cloud data warehouse, so completely offered as a SaaS service, and you have a data set, you are the data provider in that case. So the way they wanted to serve their customers or the partners, a particular enterprise and agency doing business with other people. So there are like 3 different ways at a high level data sharing can happen using a modern data platform like Snowflake. One is directly creating some reader accounts, What I mean by that is whoever is accessing this data set, the consumer, let's say, they don't need to have a Snowflake account or anything like that. Rather, provider provides a reader account and gives them a URL, and they can access the data set. So what are the benefits? So consumers doesn't need to be like buying the services of Snowflake directly. Rather, they can get the reader account from the provider in this case, and they can basically access the data. So a couple of ways this would enable pretty much the data consumption from the data partners is just by having that mere account, the reader account, they can access the data set. And they are not, by the way, moving large data sets to the consumer to even access this. So they will basically do it everything in the cloud. The data cloud runs on either AWS, Azure, or GCP underneath the CSP that they use. So customer doesn't need to, in this case, the consumer doesn't need to incur any costs to access that that way. So they and it supports multiple reader accounts. And the good thing about Snowflake is, as and when the customer base is increasing, or the consumers in this case increasing, behind the scenes they can scale up and down how they wanted to stand up a virtual warehouse, so to speak, to serve the customers. It could be 10 users, it could be 100 users, it could be 1,000 users, based on the need of the customer demand and how many people are going to use this via reader accounts. You can always scale up and down. They're like almost like 7 to 8 t-shirt sizes where the warehouse can scale. And it is a multi-cluster enabling if there is a need to basically serve the user volume like that. The next pattern is consumer also have a data Snowflake kind of a presence within their enterprise or within their business portfolio, technology portfolio. So what that means is provider shares a secure data share with the consumer, and basically they provision the secure data share in such a way that the consumer Snowflake account can recognize this and enable that sharing, and they can access it that way. The benefits of this second approach, if they so choose to basically make a copy of the data set and process within their systems downstream, however they wanted to basically using the data set, they can do that. So it's a little bit more advantageous than Snowflake. And if they don't want to do it, they can still access the provider's data set. There is no data movement. The way the entire Snowflake operates, they separate the compute from the storage. So by doing this data sharing, you're merely pointing the data set, and you're not copying the data set. That's probably one of the benefits. So account A and account B, and account A grants a share to the account B in this case, and account B has a read-only access to that share. If it is a bidirectional share, then account B also can share similar data sets to account A and vice versa. And probably the more compelling options is actually publish it in a marketplace. What we mean by that is anyone who subscribes to a data sharing or a data platform on Snowflake, whether they're using in a warehouse for their internal workloads, they can take advantage of this data marketplace, where they can access the data sets which are categorized at a higher level, demographic data, financial data, and the COVID data in the current times that we are in. If they wanted to basically share a data set, they can publish this in the marketplace and let the consumers even find through the catalog, and they can basically create a data share based off of that marketplace data set that the producer is actually publishing it. This would be a compelling option for the enterprises. Let's say I'm in a healthcare industry, and I'm serving my demographics within my service areas. I would like to marry the data set I have with publicly available COVID data set. The quicker way to get this in an old time prior to data clouds or Snowflake-like solution was I do traditional ETL, I do a lot of data dump and essentially making a copy of it into my warehouse or my transaction store or my analytical store, whatever I have been using it. And by doing that, I'm incurring a lot of costs in trying to do ETL and everything else. With this new concept of the marketplace, we are essentially basically using the data platform that is provided by the Snowflake itself and trying to leverage those data sets within my business domain that makes sense for me. So I can integrate the data set I have with the data set I can find in the marketplace. I can derive additional insights off of that integrated data sets and publish additional insights to my community, my business community. So there are like potentially, there are a lot of use cases you can tap into it. So I would like a pause here and trying to kind of connect to, okay, this is all good, right? So these are all concepts that we all do. And traditionally in the 2.0 or the 1.0, if you were to basically share a data set, I'm just trying to quote a couple of real world examples, which I'm part of in my previous life when I was executing some of those data projects. So let's take the example of, let's say, healthcare.gov. So healthcare.gov is a complex initiative that basically behind the scenes interacts with the 20 plus or so agencies across the federal government, all the way from IRS, CMS, Veterans Affairs, and it even go and basically look at some publicly available data sets as well. So needless to say, it's basically a big integration project across these agencies in order to provide the citizen services that it does. So behind the scenes, if you peel it and basically go behind the scenes, there is a need for, let's say, for an income verification, whoever is enrolled or eligibility decisions needs to happen on the healthcare.gov. There is a need for that data need to be shared from IRS to the CMS, which is fronting the whole system, maintaining the whole system. So you can think about the data implications. It is one thing to say, I'm going to get a real-time request response using a REST service from that provider, in this case, IRS, to get what I need to make a decision on healthcare.gov or that website where people sign up for buying the insurance. But the program is right now into 8 years into that existence. So they already know that 20 million and growing, the subscribers are the benefit enrollees, that they're actually getting the benefits of this insurance program from healthcare.gov. So you know that those customers are going to come next year as well during the open enrollment time. So there has to be a different way in order to set that system up. So let's, for example, the provider can actually can use a solution like Snowflake, how they can quickly this large data set to this consumer who wanted to rely on the data set provided with the provider, in this case, to make an eligibility determination or a benefit determination. You can actually do that by using this concept. So the reason I bring this up, when I was part of building that system, we went through multi-month and multi-year effort trying to get an agreement on what is the protocol, what kind of a payload I can do, what is the cadence, how my systems have to be set up, what is the security mechanism I need to use in order to give you the data that I'm doing it. And we went through multi-month exercise about writing the interagency agreements, MOUs, and ISAs, all sorts of things that anyone who worked in the federal government understands. There is this lot of I wouldn't say red tape, but these additional steps that you needed to go through in order to basically establish an interface to that particular provider or the, in this case, producer to access the data set that you need. So imagine the possibilities. Let's say if you were to redo the architecture a little bit using this data sharing mechanism provided by MDPs like Snowflake. So things would be a lot simpler, and producer can completely controls the data set. The entitlements he is actually giving to the consumer, and the security is built in, provided by the platform. There won't be even multi-month exercise in trying to do security oversight and security testing and information assurance. You can basically reduce all that additional overhead. Those are the things I can think of. That's between the interagencies or inter-companies or things of that nature. Let's say, for example, within an agency itself, I tend to give a lot of federal agencies example here because that kind of relates to people, at least the audience in this meetup. Within an agency, you have multiple business units, and you wanted to share a data set from one business unit to a different business unit. The process might not be that cumbersome that I actually said, the whole 9 yards of trying to secure the data sets, defining the data sets, and if I have to change few elements of it, the data set I'm producing, then I need to go through this cycle again. So within an agency in itself, if you are doing this kind of things, it may not be that cumbersome, but nonetheless, you are basically need to develop these interfaces, and security may be a little less because you're doing it within your firewall boundary. but these challenges would still arise. Classic case is if you look at any federal government, the missions within their agencies always driven by what kind of services they provide. So pretty much they operate in a way that it's like an outside agency in itself. So this kind of data sharing marketplace would help there. So, but they don't want to publish it to, let's say, public data exchange. That's where the create your own data exchange comes into play. What this means is this data exchange is like, let's say, you can simplify this. It's like an app store for your own organization. Apps are nothing but the data sets that you use across these business units. In other words, you provide the data exchange within the agency or within an enterprise only for the business units that you wanted to give access to. And again, one business unit becomes a producer, other business units are accessing this. They control what kind of data they wanted to share with the rest of the consumers. So it's like a walled garden approach for the data sharing problem using the modern data platform. So all the three use cases have basically gone through. The data sharing is seamless in a way that we are abstracting the entire implementation detail to the data cloud provider, in this case, Snowflake. So we are not incurring any costs in trying to do a lot of overhead. The management of setting up an exchange or setting up these shares and trying to do this, because we are using the out-of-the-box features of the Snowflake itself. Whether you wanted to do time travel, whether you wanted to do like a 90-day retention of these data sets you're sharing with somebody else, whether you wanted to take a snapshot of the data set that you're sharing and put it into an additional extra cold storage, all these things are actually provided by the platform seamlessly. And the operational overhead is very less in order to maintain this ecosystem. So there are benefits. So, and you also use it as pay as you go on model. So pretty much the amount of data that you're sharing and the amount of data you are basically storing in your Snowflake instance in order to provide that to the consumers is what you get billed on. And like I said earlier, and you have a seasonal kind of use cases where you don't need to share the data sets throughout the year, rather few months, like the healthcare or anyone works in the healthcare can understand the open enrollment period start somewhere in the November, December, things of that nature. There is that seasonal aspect of it. So you can only scale up and scale down based on producer needs. So this is all like going at a high level, but I wanted to kind of showcase what we have done in order to do this by abstracting some names, obviously, and we put together a use case here. But before jumping into this use case, so like I said, data cloud, right? Data cloud doesn't become a data cloud if it is not seamless. It's not an omni cloud. What I mean by that, Snowflake, in this case, that we are using it with some of the customers that we have been serving, they have existing relationship with all the CSPs. I mean, top 3 CSPs, I would say, AWS, Azure, or GCP. So there is a cross-region replication within the CSP itself, or if you so choose to do it a multi-cloud initiative for the data sharing, you can actually tie it with Azure. There is a replication that you can run out of the box. You don't need to run any extensive your own private links or anything like that in order to make it happen. And if the data sets are not that bigger, you can always do this using the backbone of the Snowflake SaaS provider that they're doing it, providing you to basically replicate this across the clouds and across the geographic regions. If you see this graphic, it talks about the orange ones are AWS, Snowflake running on AWS and using AWS as an IaaS, but the Snowflake itself is offered as a PaaS. And you can basically do a intercontinental replication between these regions within AWS itself. And you want to do a cross-cloud, and you can do cross-cloud replication with, let's say, Amsterdam, Azure region. So to serve your needs within the region itself. So, and it is quite complex when you get into some regional data that you don't want to ship it out to other regions, and you have some use cases like GDPR data that you have to basically store within certain regions. You don't want to even go out of the Europe. There are basically some design aspects you need to think about how you wanted to do cross-continental replication. But nonetheless, the data cloud provides you that seamless features that you can do it. There is no need to set up any additional stuff. You just have to use the Snowflake native tools as much as possible and set this replication up as tasks and different other ways you can do it. So we put together like a use case in order to basically did this with a customer of ours. So I would go at a high level, right? So there are like three agencies that this solution is basically put together for. So for example, agency one happens to be using uh, AWS for their primary workloads, not the data workloads, but their application workloads too. So we provisioned an account on AWS for that agency one as a cost producer, and we kind of replicated a data set to the agency one's Azure instance, Azure data warehouse. So the replication happens like within minutes when you set up the task and the amount of the data that you're transferring. So it happens seamlessly. And the agency one has been using AWS Snowflake instance within their native tools. What I mean by that, this particular customer, 90% of their workloads run on AWS. What that means is even their shared services tooling, the data tooling that they access, anything that is running on the AWS itself, they use AWS to even host that. So we are not reinventing the wheel in order to basically make use of this entire Snowflake within that agency current state posture itself. What that means is you can ingest a number of ways how to get into the data, how to ingest the data into the Snowflake in AWS itself, and you can use your stream processing either through Databricks, you wanted to do some sort of an ETL, or you can use basically some sort of Lambda that you already have in order to ingest the way you're doing it into the agency one Snowflake instance. By the way, you can basically run a tool like Immuta to do the governance at a finer grain level. And not to say that Snowflake doesn't provide that, they do provide those additional features too, but to get that much of data that you can do it. And it replicates the data set into the Azure that you're doing it within the agency one realm. And they wanted to share this data set with another agency, which is also on AWS, but they happen to be on a different account and everything else is different. So you can basically set up a data share and you can share with them using the native way. And here agency two is actually sharing the data set with the agency one. It's a one way from agency two to agency one. All you need to do is it's like literally peering your Snowflake with them, with the accounts that they create and the share that they create. It's that seamless, and you're not moving the data. And agency three is a different use case. So agency three happens to be on Azure, whereas agency one, they are actually sharing the data set from AWS itself. So one way it can happen is you can do replicate to your own account on Azure. From Azure, you can do a secure share to the agency three. So this is like a full end-to-end different scenarios. We are using two constructs that I mentioned earlier, the reader account construct, and also how you can share if the partner or a consumer also has a Snowflake account. It doesn't account for the data exchange part of it, but it's rather extensible to that use case too, because everything running on Snowflake, you have that seamless data sharing. The idea is you don't want to disrupt your current ecosystem. Like I said earlier, those shifts don't happen. Just like at end of the 2009, I wanted to move to data 2.0. That's not how it works, right? So you wanted to slowly kind of support your current state while modernizing your infrastructure on the data side, especially the data sharing use cases that you have serving the customers. With that, I will take a pause. I think we're kind of wrapping it up at the end of it. Sabrina, I would give it back to you for any further Q&A questions. At a future meetups, we would actually like to demo this with a real demo by doing this data sharing. How quickly, how seamlessly you can set this up in days, not weeks, not months. Within days, you can set this up, provided if we have all those accounts and everything ready.
Thank you, Siva, and thank you, Sinu. We have a few moments for questions and answers. If we want to go to the next slide, or if anyone wants to unmute themselves or turn on their video, raise a hand, we can discuss some questions if anyone has any. Seeing none, I will say that this concludes our Navitas Presents data sharing using modern data platforms. So thank you very much for tuning in. For more information on how to transform your business through data sharing on data clouds, or to learn more about Navitas, please visit www.navitas-tech.com.
Someone has a question, Sabrina.
Oh, sure. Whoever has a question, can you unmute yourself?
Hey, this is Shri. I just had a question for you guys. One of the things that you probably did not touch on is the size of the data. Can you shed some light on what was the size of the data that you were sharing between the three agencies?
Yeah, so that's a very good question, right? So we always talk about this data cloud. Needless to say, there are intricacies. So we're talking about at least gigabytes of data, other terabytes of data from a continuous data sets we wanted to share. So the way it works is, at least from a solution standpoint, when you are setting this up, even if it is gigabytes or the terabytes, since you're not really moving the data or copying the data, you are only merely creating a pointer to that. When you share with a data account, or when you share a secure share to a consumer, in this case, who also has Snowflake account, the size really doesn't matter, because producer is already paying for that cost of provisioning the data set within their warehouse or the virtual warehouse. They're just merely giving a pointer to the consumer. It could be one consumer or 10 consumers. You're not making 10 copies, rather one copy, and giving that pointer to 10 people. So data size doesn't really matter there from realizing the cost savings. In your traditional world, you would have to end up doing a lot of copying and ingesting within your ecosystem and trying to make sense of the data, trying to ingest the data into your own business use cases. Did I answer your question, Sri? So size is like gigabytes or terabytes, it doesn't matter, but you can actually scale it up your size needs. You can go to petabyte scale too, if you so choose to do that kind of data sharing.
Yes, thank you.
Thank you for that question. We have another question. What are the challenges around data governance and security, especially cross-cloud?
Yeah. That's a another important question related to security. When we say data cloud, unless you can provide that security posture from a data cloud provider, in this case Snowflake, you cannot really preach those omni-cloud things that your data is always secure, right? So good thing about the data infrastructure the Snowflake runs on, it actually caters to FedRAMP High and FedRAMP Medium assurances based on Gov clouds that they are actually deployed on. So that means security comes as part of that. Another thing, you can actually control at a fine-grained level. Let's say you're sharing a data set, and you can so choose to only give, let's say, out of those data sets, and if I'm talking about in a relational sense, I wanted to share like 5-6 columns of this data, a few millions of records with consumer A, and I wanted to do with another additional columns only with these other consumers. I can actually define that as a policy and put it inside the Snowflake, and it gets enforced during the runtime. That is one thing. From a data security standpoint itself, they use a tri-key algorithm. What that means is customer can bring in their own keys, or they can use cloud provider keys in order to encrypt the data. And the data in transit is also secure when we share the data sets with a different region. The data replication happens on the so-called backbone of the CSP itself. And it gets secure in that way, but we don't stop there. We also encrypt the data when it actually leaves a particular region.
There's one more question in the chat from Michael. What kind of tools are embedded in Snowflake? Is it a microservices approach?
So Snowflake has various tools within, like for ingestion, they have all the way from Snowpipe and external tables, so that you wanted to source the data from S3 and things of that nature. and it's purely 100% ANSI SQL compliant. So all your traditional SQL tooling that you can use in order to query a warehouse, query a transactional store, and analytical store, you can use that. So you need to use additional tools that you already have within your organization that you wanted to use as a warehouse. So you can basically bring in the options that you already have. You don't need to procure or buy anything new because they do support standard drivers, ODBC, JDBC with any BI tooling, any ETL tooling, anything like that you have.
Thank you, Siva. Yeah.
Thank you. Bye.
Well, that concludes our Q&A and our Tech Talk. Thank you very much for attending. And again, thank you very much to Siva and Sinu for putting this together.
Thank you, everybody, for taking time to attend this.
Yeah.